Welcome students, we've been given this question. Evaluate limit n tending to infinity of 1 over square root of n squared negative 0, positive 1 over square root of n squared negative 1 squared, and so on it goes up unto 1 over square root of n squared negative n negative 1 raised to the power 2. Now foremost, what I wish to do is I would like to convert this particular quantity as a summation series. So I can rewrite this as sigma 1 over, this is going to be square root of course it has to start with n squared. Now instead of n negative 1 raised to the power 2, I'm going to substitute k there. So k will actually ask to start from 0, because when k is equal to 0 we would get the first term. When k is equal to 1 we will get the second term, n squared negative 1 squared, and so on it goes. So for producing this term I need to have the value of k stretch all the way up onto n negative 1, because when k is equal to n negative 1 I would get this last term which is present here. Now having obtained this summation, what I wish to do is I would like to take n squared out. So this would mean I got limit n tending to infinity of sigma k is equal to 0 to n negative 1 over, first I would take n squared out, so that would mean I got 1 negative k squared over n squared, and that has to be placed within the square root. So this is what I've got. Now if I were to take n squared out, this would give me limit n tending to infinity. The moment n squared comes out, it will lose its square because of the presence of the radical sign. So I'm going to rewrite this as sigma 1 over n times square root of 1 negative k squared over n squared. Of course k varies from 0 to n negative 1. Now this can be further rewritten as limit n tending to infinity of, I'm going to take 1 over n out and rewrite this as sigma k is equal to 0 to n negative 1 over root of 1 negative k squared over n squared. I want to write it as k over n raised to the power 2, and I've got a summation in this fashion. So this is limit of a series, and this can be rewritten as a definite integral stretching from 0 to 1 dx over square root of 1 negative x squared. Okay, now we need to integrate this. So to integrate this, I would like to take x to be equal to, say, some sine theta, and from here I get dx is equal to differential of sine theta would give me cos theta times d theta. Now this is equal to, I'm not changing any limits, I'm just retaining it as it is. So in place of dx is going to be cos theta d theta divided by square root of 1 negative, my x is sine theta, so this is going to be sine squared theta. Now we know that 1 negative sine squared theta is equal to cos squared theta. So this would mean I now have integral cos theta d theta divided by root of 1 negative sine squared theta is cos squared theta. This can be rewritten as integral cos theta d theta divided by square root of cos squared theta will give me cos theta. Cos theta can be cancelled, giving me integral of d theta. Now integral of d theta is theta. Of course I need to place the limits. Now the limits has to be placed, but before I could place the limits, I would want to revert it to the x component. So let me write it down here. X is equal to sine theta, so therefore theta is going to be sine inverse of x. So I'm going to substitute sine inverse of x. The limits are, since I have not converted or add the change of limits here, I can simply place the limits to be 0 to 1. So this would mean substituting the upper limit, sine inverse of 1 negative sine inverse of 0. Now this would give me 0. Sine inverse of 1 is going to be pi over 2. So the solution for this question is, therefore, limit n tending to infinity of 1 over root of n squared negative 0 positive 1 over root of n squared negative 1 squared plus up to 1 over root of n squared negative of n negative 1 raised to the power 2 is pi over 2. So that is the solution. Thank you, students.